ever outside.
I can't do this anymore.
You can do this. You can do this.
This class is so creepy. Oh, I have a question.
Yes.
When you put all that stuff in on Blackboard, is this class not weighted anymore?
It is weighted.
Okay, because it's not on there anymore. It doesn't say.
That's because the weighted total was wrong. It was counting everything, like your test was the same as that little 5-point lab. And so I had to separate them, and I put a column of tests and a column of labs, and I'll put a column for attendance, and I'll put a column for survivor. And so tests are 70%, and so I'll give you a formula for it. Oh, that was in your syllabus. Tests are 70%. I know. You're not dumb. You're not dumb.
That first test was a 45%.
Listen, I'll tell you what. Studying for anybody new that you haven't had before in a content class, that's some rough crap. I mean, it is.
Are you teaching the other one of these?
Yeah. Yeah, so you'll be used to it. You'll know what to
And
expect.
then you do science methods too, right?
Mhm.
Oh, we'll be together for two more semesters.
All right. Oh, hi, guys. Okay, so.
Dr. McKean.
You have a little hole in your shirt.
I know. I need to sew up my stuff. It's these big teacher bucks they pay me. It's like 5-year-old shirt. All right, so we are moving on from magma to minerals. And the little bridge to get us there is something called, whoops, I better share that with my people at home. And the way to get us there is something called Bowen's reaction series. So I have a handout, but the handout is this picture right here. And I suppose I should let you guys in on this too. Like my second class is always filled. Like, I don't know. I do know I have swimmers, softball going, and I have Lacey's at home and Abigail's at home. 1, 2, 3, 4, swimmers, softball. I don't know. We're still missing 3 people. So.
Dr. McKean, I have a question.
Yes.
My group is at 1 o'clock, but my kids go to school at Blackshear and Mannington, and walkers are let out at 2. Am I allowed to start coming at noon? That way I can come face to face?
Absolutely.
Okay, that will help me out a lot. Thank you.
Yes, absolutely. If there's ever like a discrepancy, we can hear everything. If there's ever a discrepancy for anybody who needs, like, oh my gosh, I can come at 2 or 1, but I can't come at noon. I understand, but you got to reach out to me. So let's start with Bowen's reaction series. So you guys have this, and I picked the printout that had the most information because I want you to take some notes on this. We start at the top because this reaction series is the cooling down of magma. So we went through, what happens when magma comes through the crust, and it creates volcanoes, it creates supervolcanoes, island arcs. There's all kinds of different things that happen with plate tectonics and magma. However, we haven't talked about what happens when magma finally cools down. Well, that's where we get minerals. Minerals are the result of cooling magma. Minerals, so write that down. Minerals are the result of cooling magma. You're going to read Bowen's reaction series from top to bottom. And you might think, well, of course, we read everything from top to bottom. But no, when we get into geologic time, we will read it from the bottom to the top. So I just wanted to make sure I point out, we read this from the top to the bottom when we're talking about forming minerals. So the formation of minerals is top to bottom. The melting of minerals to go backwards and form magma, that's when you go from bottom to top. Okay, so let's talk about some of the things you see on this. So we see temperature, of course, that's in degrees Celsius. So the hottest forming minerals are at the top, and they begin to form when magma hits 1400 degrees Celsius. That's the coolest it has to get. Now, that's still not cool, but that's the coolest it has to get for things like olivine and plagioclase feldspar that's rich in calcium. I know, it's okay. It's okay right now. But for that to form. So right here, you'll see olivine that forms at 1400. And then you see calcium rich. Calcium rich what? And it's plagioclase. It's just a type of mineral, and there's tons of them. And it's a, oh my gosh, please don't, okay. Oh, this has certainly been a Monday. This is. Deb would kill me because I have done that before. So this mineral, this feldspar, is rich in calcium up at the top. Now, you have two different branches. You see where it says olivine, pyroxene, amphibole, and biotite? That is our discontinuous branch. It's called discontinuous, and that's on your handout. It's discontinuous because it doesn't just flow. Yes.
What is feldspar?
Feldspar?
Yeah, do I need to write that?
Plagioclase is a type of feldspar. It's just a type of mineral. And we'll look at it here today. Like, that's not something that, you know, oh, I have to know my feldspars for exam number 3. No, I just want to take you through.
But we do need to read the second half of the book.
Oh God, yes.
Oh, God.
Okay.
Wait,
Yes.
when is this? When is the third test?
How quickly do I need to read this second half?
Remember that day that I said, take this day and read your book?
No, I read the first half that day.
All right, you should have been reading the second half that day. All right, but anyway, before this next exam, like within the next 2 weeks, get the rest of that book read.
I'll read it this weekend.
All right, so up at the top, I want to give you some ideas about how to remember this stuff. So you see the word mafic, and you're probably thinking, never heard that before. Okay, you haven't, but you do know what that is. Mafic is basically the same as basaltic magma. So anything that's mafic, out from that, I want you to write basalt or basaltic magma. Do you remember what color your, in plate tectonics, do you remember what color the oceanic plate, which was made of basalt? They were really, really dark. They were like black, dark green. So everything that's up at the top is dark in color. It's dark and it's very dense. So everything that's mafic is dark and dense. Dark in color, dense in density, heft. Now, as we cool down, this is where the discontinuous branch gets kind of weird. Olivine turns into pyroxene. Like once you get to about 1300 degrees, olivine isn't made anymore. It's like done. It is discontinued. And you turn into pyroxene. And then you drop another 100 or so degrees, and then pyroxene gets discontinued and it turns into something called amphibole. That's why it's discontinuous. It's because these things kind of disappear and you're left with these brand new minerals. All the way down to roughly about 1,000, 1,100 degrees. And you see biotite And then we get sodium-rich plagioclase feldspars on the other side. So right down, yeah, so right about there, it's about 1100 degrees, 1200 degrees, approximately.
At the peak of the line.
At the base of the Y, you get right around 1100, 1200 degrees, right around that little bottom. Yeah, you've got that too. Okay. Well, this is also where your magma changes. So these are kind of medium in color.
Or intermediate.
And they're medium in density. And this is the andesitic magma. So once it says intermediate, out to the side, put andesitic magma. And so for those of you at home, we are right here. I wish there was a way to annotate this. Okay. Andesitic? Sure. So I got my doctorate. No, I'm just kidding. I was going to spell that stuff. All right. So this is where you get, in plate tectonics, you get like an oceanic plate with a continental plate. And that's the magma that forms the sodium-rich feldspars or the biotite, just depending on which branch it's forming from. So if it is forming from the oceanic plate, you'll get the biotite. If it's forming from the partially melted continental plate, you usually get the sodium-rich plagioclase. So what happens on the continuous branch is that calcium starts first. And calcium is the main ingredient of this mineral, of this feldspar mineral. And so it's really dark. And then as the temperature gets cooler, calcium no longer is formed. Kind of in the middle here, you kind of have, oh, look, sodium has popped up and it started forming. And so you have like a nice mix, a continuation of calcium all the way until calcium gives way to all sodium. And sodium is lighter in color. So everything in this part is kind of medium colored. You get like buffs, you know, some really light greens, you know, they're pretty. I like minerals and rocks, but anyway. So they're lighter in color until these two branches come together. And all at the bottom, you see the word felsic. That is your rhyolitic magma, formed mainly from the melting of continental crust. It is rich in silica. So when I say that, I look, oh, look, it's got Si in the word. It's rich in that. For mafic, it's rich in magnesium. Oh, look, it's got Ma in the word. So there are ways that I try to think about, like, how do I remember what that's rich in? It's a dark color, and this is a light color. So orthoclase, feldspar, muscovite, and quartz. So we go basically from white colors all the way down to clear. And so your minerals start hot and dark and dense, and then they gradually change to light color, light density, like they're not very dense. These are the lightest minerals on earth. Light in color, cool, very, very cool. So they are the last ones to form because the magma has to cool down to at least 800 degrees for quartz to form. Then the flip side of that is that those are also the first ones to melt, because they melt at 800 degrees. And that is how you read that action series. This basically gives us a guideline of, in a perfect world, which we do not have, but in a perfect world, if we were to cool down all these different magmas, we would get this in that order. So this is like the make-believe fairy tale of geology, but it's what we go by. Doesn't always happen in real life. Luckily, I'm not taking you out to say, at what temperature did that form? It's not like that. You just have to know how to read that. You will be given this picture for your test and your final. That's not something that you have to memorize. This I haven't had a chance to label is hydrochloric acid. It's not super, do you have a Sharpie by any chance?
Yeah.
Can I see it? Thanks. Okay, I don't know how old this.
I have a Sharpie, a black one.
Oh, this is working. So HCl, don't get it in your eye for goodness sakes. You're going to be using 1 drop throughout class, just like to test your minerals. So those of you at home, I'm going to stop sharing. And we are going to be moving on to, we have a hands-on activity today, and everybody has a bag of minerals and a little placemat. And that's what we're going to be working with right now. So take your mineral placemat, and it looks like this. And I will post this online for those of you at home. And just spread your minerals out. Make sure you have 14. If you don't have 14, I'll try to figure out which one did I have. Yep.
These two things, minerals, these two little flat things.
Yeah, those are minerals. And it's the same mineral.
I'm missing one.
Okay. Let me,
So if I have 2 of those, I don't need a third.
I have
Correct.
some extra.
oh, great.
I didn't put these back very nice.
I know, I saw that because I was like, oh my gosh,
Are those
they are
things
everywhere in here. What's that?
Is this a mineral?
Yes.
Well, I have a
Oh,
lot of extra stuff.
hold on, that's a mineral? I did
Oh,
not think
yes.
it was. It
I
was
have- Okay, that's what I was going to give you.
It's very flimsy, so.
I need one more.
Let's see which one you need.
Can you use the clear one that I just pulled out?
Oh, good.
This thing?
Yeah, that's a mineral.
Yeah, that's
I
a
like this
Oh, I
mineral.
already have that one.
That's it.
Nope, it's different colors.
You don't have to clear one.
Well, I thought you said that they were the same.
No, I meant this.
I know, minerals.
I think this
can
is
be
it.
confusing. I'll look at you with all your
I'm just
mixed
gonna
up. Yay, good. All right. Do you need some more?
No, I have a lot of extra.
All right, we're gonna put these two together because they're the same thing. That is the same as this. She needs this. All right.
What about this?
I just wanted to.
What about this one? And there's 2 in this one. This.
Oh, hold
There.
on.
Is that
Let's see
right?
if those are the same thing. I think this is the
I
same
actually
thing.
think I have 2 of the same here. And I don't have that. But you can.
Let's see.
This
Is
could be
this
that.
not the same as this?
Do you have this heavy one?
I have
Like
like
you have one
3
that
of these.
feels real heavy.
Oh, yeah.
Okay.
Does this one, is this, let's see. This is the one I had the question. Like,
Yeah.
okay.
Yeah.
Whatever she-
I like this pink one.
I love
I
that
don't
one.
have a pink one. Oh, yeah, I do.
All right, so now that you have 14.
Yeah.
Take a look at your exploration. And, yeah. And you can talk with a partner, you can talk, we've got 5 of us here. So you need to talk to your partner and figure out, what do you think a mineral is? How is it different from a rock? So those of you at home, think about that. How is a mineral different from a rock? All right, so they are just working on writing down their explanation. And let's see here.
Minerals, igneous rocks.
They are all igneous in nature because they come directly from magma. Well, I shouldn't say all of them, most of them, because some of them are secondary, but we won't get into all that good stuff. All right, so who wants to tell me what they think a mineral is?
We just wrote multiple different elements make up a mineral. They come mostly from magma.
Okay, so lots of different elements make up minerals. All right, yeah, you're right. And they come from magma. Almost all of them do. And is there any other requirement? Well, let's take a look at that. I want to share, let me make sure I get this back on. Bad eyes, bad shirt. This is quite the Monday. It's okay.
Your shirt still looks good, even though it has.
Thank you. All right, so there are 5 things that it takes to be a mineral. Do you have what it takes?
Right here?
Yes. Yeah, so if you turn your paper over, thank you. Where it says concept development, geologist's definition of a mineral must meet 5 criteria. It has to be naturally occurring. Like we can't make them ourselves. If it's man-made, nope, not a mineral. So naturally occurring. They are solid. All minerals are solid. They cannot be, so tar cannot be a mineral. Water, not a mineral. They have to be inorganic. So that doesn't mean that you can't find them in the organic section of your supermarket. It means that they could never have come from anything living at all. They are inorganic. They were never, ever from anything that was living. So that means coal cannot be considered a mineral because that coal came from coal swamps. So all that plant material was living. So coal is definitely not a mineral. They are all crystalline. In other words, they have a crystal structure, if that's a better way for you guys to understand it. And most of them have very different crystal structures, but they all have some type of crystal structure, whether it's in layers or whether it's tetrahedron like a diamond. You know, they all have something. And they all have a very specific chemical composition. They have to have a specific chemical composition. Not just willy-nilly put those elements together. It's specific, like quartz, SiO2. Forever that's quartz. Silicon dioxide. If it's something different, then it's not quartz. Now, a mineral could have impurities in it, but those impurities are not considered part of the mineral. Everything that's SiO2 would be quartz. But the pretty pink comes from some different impurities in it, makes it look better, but the impurity is not part of it. Maybe. All right, so I'm going to stop sharing that. And we're going to share, I'm going to share the whiteboard because I got some stuff to say. Now, and I want you to make sure that you can read it. So we are going to look at common properties used to identify minerals. So the first thing, minerals have lots of different properties. Not all minerals have the same thing. So minerals might have luster. Luster is a nice geology word for shininess.
Is this for the,
Mhm.
the assignment? Okay.
Yeah, this is for part B.
Okay.
The common mineral properties. Now, here's the thing about luster. It can be shiny like metal. Guess what that's called? Metallic luster. Remember, as a geologist, we're not that creative. Or it could be shiny like glass. And then that's called vitreous luster. All right. So luster is one of those properties. And there's like a couple of subcategories for luster, but it's still one property. So it could have a metallic luster or a glassy luster. All right, the second thing is streak. It's the color a mineral makes in its powdered form. So when you take something called a streak plate in these little tools, of course this man,
You need some new supplies.
I do. New bags and bags of grip. All right, so these little white tiles are streak plates. For those of you at home, this little, where is it? There we go. This little white tile is a streak plate. And what you'll do is, let me have your shiny one. So if I looked at that, what color would you call that? Okay, gray, silver, sparkly, whatever. But when I make a line, what color is the line? It's brown or dark red. So streak is, that's that powdery form that it makes when you write with it. So streak is the color of a mineral in its powdered form. It's like when you're drawing with it, it leaves behind a powder. That's the streak, not the color of the mineral itself, but the color of the mark it leaves behind. That is for sure. Let's see, hardness. Exactly what it sounds like. How hard is it? Well, we have a scale called Mohs, not moles, Mohs hardness scale. And it goes from 1 to 10. 10 being diamond. Nothing's harder. No mineral is harder than a diamond. There are some that are similar to it, but that's the one that you would most likely know about. And then you have things like quartz, which would be a 7 on the hardness scale. And we'll learn about what it takes to, like how we rank them. Now, if you can scratch it with your fingernail, it's really, and you have a mineral there that you can do that with. So it's going to be real low in hardness. If you can scratch it with a nail, that, it's up in hardness. And then some minerals, you can only tell the difference because one scratches the other, and then you rank them. So hardness, and we'll get into that a little bit more. There are some that are very easy to understand. Magnetic. Some minerals are magnetic. Color is a property of minerals. However, that can change when minerals are wet. Minerals are dry, if it's cloudy. So color is the least reliable. It's the least reliable property. Oh, let's see. Some minerals have cleavage. All that means is that they break in a very specific shape. So you guys have minerals with cleavage on your desk. And let me tell you something, when you introduce this to some of the kids won't get it, like when they're 4th and 5th grade. But by the time you have to talk about this in 9th grade, cleavage, kids are crazy. So try to find 2 minerals right off the bat that have cleavage. Yep. Yep. If it breaks in a specific shape. Is that a very specific shape? That's a rhombus. Yeah. It has rhombic cleavage. And this has sheath cleavage. And this,
The clear one.
and this one actually has like cubic. Some of them are harder to tell than others, but it has cubic cleavage. So, and then the opposite of cleavage is fracture. Looks like a clump. So when you break it, doesn't really make shape. It just looks like a clump of mineral. And this can be hard. Can I take your pink one? So quartz is considered to have fracture because it's just not really a shape. That being said, you can find quartz crystals deep in caves that are near, usually like near places that have had some volcanic activity millions of years ago. But anyway, you can find them and they're shaped like a giant crystal. But don't let just finding a single crystal, like if you broke that crystal, you'd get all those little clumps. So clumps just mean it doesn't break in a specific shape. How many have we hit? Okay, I'm trying to see. Heft, we'll do heft. And you call it heft in the field because you don't take a balance with you in the field to measure your, to measure. So if it feels heavy, it has heft. It's also known as specific gravity. It's basically the density. Of your mineral. Now, the good news is, even though I've forced you to do the math of this before, that's not what I'm looking for here. Find the mineral on your placemat that has the greatest heft. It should feel the heaviest in your hand when you pick it up. Doesn't matter what size it is. Yes, yes, yes. Yes. Even though it's one of the smaller ones, it feels heavy. Can I see yours? Well, you're right, and that's because that one has a lot of iron in it. But it is this. All right. So with that being said, Galena, which is what you just handled, we are not allowed to bring that into schools anymore for the elementary kids because they tend to lick it. It's a lead-based mineral, and so it tastes a little bit sweet.
Why would they?
Oh, I mean, I licked my salt rock.
Oh yeah, like I've got a salt rock on my desk. I'm like, here, I'm like a super spreader event. Like the kids always want to lick that. But the galena is a lead-based mineral, and like the ancient Romans, ancient Greeks used to use it to make cups and bowls and things because it would give it a sweeter taste. Because lead tends to do that, but then they end up with, yeah, mental conditions and so, yeah. It's not a good trade-off. So, just as a forewarning, if you bring galena into the classroom, make sure the kids have gloves on, or just make sure that they wash their hands real well after, and you guys should wash your hands real well after we use it. Don't lick science. That's just a good thing to live by. Okay, so those of you at home, those are the basics that we're going to deal with today. And I think we have enough time to do our flow chart. So, what I want you guys to do here in class is put all of your minerals on top, all 14, and then try to figure out where they go.
But they all go in there?
Yep, they all do. There's a place for all of them. So, for those of you at home, let me make this bigger for me. I'm going to stop sharing this. I'm going to highlight me, spotlight me. So, yeah. This is the placemat that we are using right now. And they're going to take all of their minerals and put it exactly where it says all minerals. Now, we're going to split them up into either they have a metallic luster or subluster. If they look like metal, put them under metallic or submetallic luster. If they look like glass or they're not lustrous at all, put them on the other side. Okay? So have you done that with all of them? Okay. Now we're going to move down. Go to your metallic ones. If it has a reddish streak, go straight down and you figure it out what you have.
How do we know if it has a red streak?
Well, remember those little tools I showed
They
you?
weren't in here.
They weren't
Of
in
course
there.
they were.
That's why we don't know.
Sorry. So here are some tool bags. Not all of them have all the tools you need. That one does. And you guys can share.
There's only 5 of us.
So use the streak plate. So they're going to use the streak plate, the little white thing, and they're going to just rub their mineral on it to see what color it leaves. On the other side, they're going to figure out, does it scratch glass or can it be scratched with a nail?
What if it doesn't leave anything?
Is there one that says that?
Like this guy right here, this doesn't do it. So
But if it marks paper, you guys know what marks paper?
Yeah, that one's over
Is this one the one that breaks into sheets, the bio type?
Yep, and it's dark.
And this is quartz?
Yeah.
Can I see that?
And you said this one doesn't leave a mark at all?
Is this the gold color? Yellow?
Let's see. you don't have pyrite.
Um,
I don't know why. Oh, you have some? Well, that's crappy. You
Oh,
can't tell that.
Is that pyrite?
Only the little gold clusters in there.
What do we do with this?
Here, let me see if I can find you a,
Is this one the graphite?
does it write like a pencil? Yeah. There's no. Here we go. Here's a tiny little bit of pyrite. Can you see it in there? It's like gold.
Yeah.
Okay. So that's your pyrite.
And this is something different then?
Yeah.
I knew it was that.
And I think I'm going to shut down our.
How do you know the?
So for those of you at home, what they're doing right now is just going through their minerals.
How do you know
And-
if it's magnetic? Is this one?
There's a magnet in your toolkit.
Oh.
And so they are trying to figure out which one is which based on this flow chart. So do you guys at home have any questions? I'm going to post your lab. I'll post everything on there. And the last thing they have is a concept application, which is the flow chart. And then they're going to go back and actually list the correct minerals in their placemat. Like once I tell them. All right. So do you guys have questions at home?
No questions. Erica's gonna bring me, the lab sheets to our, we have
Okay.
a night class, at 4:30 tonight. Thank you.
You're welcome. Lacey, if I post them, oh, I will post them, but you're welcome to print them off.
Okay,
All right. Bye, guys. Have a good day.
bye.